So now we're on the roof of NE1, and on the roof it's a really a good way to really get an understanding of what type of systems we run in the building. Going to the roof is it's very helpful. What we're going to do here is first of all we are going to look at each equipment and try to get as much information as we can from the name tags that are on the equipment, and again also have understanding of how our equipment is or equipment layout, and how each system serve what part of the building. Of course, if we have access to mechanical drawings, we can get a lot of information from the drawings, but it's always good to see what happens in the past few years if things change and more units are added or replaced, and some of the ducting configuration may change. So going onto the roof and see what's there is always a good thing. Sometimes you go on the roof and you see equipment that you're not going to be able to get much information from it. For example, we can see mushroom exhaust fans that you're not necessarily going to be able to see what the motor is running that mushroom exhaust, but at least you'd be able to know it's there, and maybe look in documents to see what is the CFM of the exhaust fan, and what the horsepower of the motor, for example. Another thing that I personally like doing is spend a little time on the roof and maybe take a piece of paper and draw on that piece of paper the roof layout, and put all that equipment on that piece of paper, so I can go back to the office and I have it in front of me. I remember that it was there, and I have pictures to compare it with the layout on the paper, and kind of really understand what's going on. So let's go and see all the equipment that we see here. We'll look at condensing units. These condensing units are usually serve server rooms or any types of rooms that need additional cooling capacity, that is supplementary cooling other than the main cooling system that we'll see in a little bit. We're also going to see, as I mentioned, some exhaust fans. We'll number them. We'll try to see if we can hear if they're running, if they're cycling, give us an idea of how they're controlled. We're going to look at the rooftop units. I can see from here that the east side of that building has quite a bit of a number of rooftop units. These are packaged rooftop units. I can tell that they have cooling, and they're probably gas-fired rooftop units. So what we'll do is we'll go there, we'll listen to how they operate, we'll take notes, we look at the name tags, and we'll make sure that when we have information on all of these units. So remember, we want to make sure that we capture all the exhaust fans on the roof, because if exhaust fans are left on during the night when when the building is unoccupied, we remove a lot of warm air from the building, and that's a big waste. So first of all, we want to make sure that we know all the exhaust fans in serving our building, and we also want to make sure that they're not running after hours. And if you can't do a night audit, you can only do a day audit. You kind of want to make sure that it's running during the day, and then make sure that there's some kind of control to that fan that will shut it off at night. In this case, it's not a very typical case, but in this case we have a tag on the mushroom that tells us what that fan serves. This happens to serve room 340, and it has 1 horsepower fan. So it's good information that you will need for your end use breakdown. And another information that you might want to look at is CFM, if you realize that fan is left on during nighttime, because that would be very easy to justify to control it better. Here, this is a cooling tower that serves our cooling chiller in this building. We can see that you can see the round shape of the top of this cooling tower. That indicates an induced draft cooling tower, and you can also see the motor that runs that fan. And you can easily take look at the name tag and see what how many horsepower that motor is. So I look at here and it's a 20 horsepower motor. So that's what drives this induced draft cooling tower. Hopefully we'll have a variable speed drive that will control that motor. So we go down and see what's behind that cooling tower. So as I was hoping to see, here's the variable speed drive that controls that the motor of the cooling tower fan, and modulate the speed of that fan as cooling load increase. We increase the speed of the fan to reject more of that heat to the cooling tower. Starting from the first rooftop unit, we're gonna look at every unit, because every unit might be different and might be different from the original design. So again, if you have access to a mechanical drawing, it may or may not be the unit that you end up seeing on the roof. So if you look at this rooftop unit, for example, again, this is a packaged rooftop unit. It has a cooling system, so it has the compressors in it. It has the condenser side, and the evaporator, which is past the fan, which is inside that package unit. This example of York rooftop unit is actually all electric. So out of all the rest of our rooftop units that we see here, this is the electric one, and heating is also done electrically. When we do the inventory, we're gonna look around the unit to find where that name tag is, where we're gonna take all the information that we need, like the horsepower of the fan, of the blower, the horsepower of the condenser fan, which is the outdoor fan that is located on top of the unit. And we look for the compressor size and the capacity of each compressor. One part of this label, or one part of our equation, is missing there, and that's the CFM of this unit. Most cases you're not going to find the CFM on the name tag, and you will either have to find it in the balancing report, or or search the model number of that unit and get the CFM from there. And obviously that's a very important variable in our equation. When we do our ventilation load calculation, we have to have some kind of an idea of how much air is provided from that unit. So that's one thing. And the second thing is you might want to look at this specific unit, is that you'll see that we have some kind of a closed damper here, and two more intakes on this side. And what that tells us, that this unit has an economizer in it. And basically, when you need cooling in your building, this unit knows that you can take advantage of cold air from the outside and bring in more of the cold air, more than the minimum requirement. And at this point, you bring a lot of extra air, and that air will need to be relieved somehow. And this is the relief damper that will basically open up to let go of some of that pressure buildup as you bring more air into the building. Here we have another rooftop unit, very similar to the York unit. This is the Aeon rooftop unit. Again, it's a packaged unit. It has cooling and heating, and you can tell right away by the yellow pipe that this is a gas-fired unit. And you can see that there's the exhaust for the combustion gases from the burner inside that unit. So similar idea. We're also going to look at the name tag of that unit and pick up all the information required and needed for our audit. And you can see also the duct system connected to that unit. You can see the return and the supply ducts. So if you come back here, you'll see the name tag, and here we'll take a picture and we'll write down again all the information that we need.